This section is about energy resources and transfer. The section covers energy transfer, work, power and energy, and electromagnetic effects. First, energy transfer. One familiar form of energy you need to know about is heat energy. Heat, or thermal energy, is transferred in three ways: by conduction, by convection, and by radiation. Watch this clip and spot which kind of heat transfer is taking place.
Energy can be released as heat. So when we say how hot something is, what we're really talking about is the amount of energy it has. Now, energy always flows from a hotter area to a cooler one. This metal bar is covered in a special material that changes colour when it gets hot. The energy is transferred from the water to the bottom of the bar, so it gets hotter. And the changing colours show the energy transferring along the metal. But what is actually happening?
Particles in a solid are vibrating all the time. How much depends on how hot they are. More energy means more vibration. The metal bar is heated at the bottom and the energy moves from one particle to the next, making each in turn vibrate faster. The energy always moves from hot areas to cooler ones.
That clip was about conduction. We saw how heat is transferred from where there is more to where there is less. During conduction, heat moves through a material from a warmer to a colder part. Heat can also be conducted from a warmer material to a different colder material if they're in contact. This explains why a glass of iced water feels cold. Your warm hand is losing heat by conduction to the cold glass. But how can heat be conducted without movement of the material itself? Well, when part of a metal becomes hot, the atoms vibrate more rapidly. They have more kinetic energy. They pass the energy onto other atoms they touch, which in turn vibrate more rapidly. Metal atoms also have fast-moving outer electrons, which can move through the whole structure and quickly pass the energy throughout the metal. Good conductors of heat are materials that allow heat to travel easily and quickly through them. All metals are good conductors of heat, which is why metal spoons in hot liquid or metal saucepan handles quickly get too hot to touch. Insulators are poor conductors of heat, materials that do not allow heat to pass through them easily. Plastics, glass, and wood are examples of good insulators. Convection is another way that heat travels from one place to another. If you have a heater on one side of the room, the heat gradually spreads throughout the room. How does this work? The air around the heater gets hot. It expands, becomes less dense, and rises. Colder air sinks and moves in to take its place and is, in turn, heated. This movement of air forms circular convection currents. So, convection transfers heat by the movement of particles. Convection, therefore, only takes place in liquids and gases, where the particles are free to move. Warmer parts of a liquid or gas gain more energy, expand, become less dense and rise, while colder parts fall. This creates convection currents within the liquid or gas. Radiation is the transfer of energy through empty space. Radiation doesn't need any material to travel through. It can travel through a vacuum. The sun's energy warms the Earth after travelling through space. Radiant energy, or infrared, is emitted as electromagnetic waves from objects. All objects give off some heat radiation, and the hotter the object, the more heat radiation it gives off. When an object absorbs radiant energy, it becomes hotter. The amount of radiation emitted or absorbed by an object also depends on its surface. Silvery and white surfaces are good at reflecting radiation, poor at absorbing it, and poor at giving it off. Dull dark or black surfaces are not good at reflecting radiation and are good at absorbing it. They're also better at emitting radiation. Buildings in hot countries are painted white, so they reflect heat radiation from the sun and keep cool. We also wear white clothes in the summer. So, light, shiny surfaces are poor emitters and poor absorbers of radiant heat, and dull, dark surfaces are good emitters and good absorbers of radiant heat. To sum up the transfer of heat energy, we feel the heat of a fire in all three ways: directly by radiation, through hot air rising by convection, and by conduction through the ground or the fire surround. This is a cross-section of a vacuum flask. It can keep things inside it cool or hot, so it's designed to stop heat escaping from or getting into the flask. Use what you know about how heat travels to work out how it works. Well, heat can travel in three ways: by conduction, by convection, and by radiation, and a vacuum flask uses several tricks to stop all three. The screw top stops convection from hot liquids through the neck of the flask, and the stopper is plastic, a good insulator, so that stops conduction. The inner container has a shiny surface to reduce heat loss or heat gain by radiation. There's also a vacuum between the two skins of the inner flask that stops heat travelling by convection and conduction. The cork pad supporting the inner flask is a good insulator, so it reduces conduction.